Hello everyone. Today I'll be discussing with you all 4th of September 2020 JEE Mains morning slot paper. I'll be concentrating on organic portion of this particular shift. So let's start with the paper discussion. And here is the paper. Organic question is starting from question number 2. Here is our question. Now see, it says the IUPAC name of the following compound is. If we observe this compound, the preferred functional group is certainly COOH. So most preferred position will go to that is position number 1. Now we have two choices, this way or that way, like coming this side 1, 2, 3 and getting bromine in position number 3, or going this way 3 and 4 and then 5. So bromine is getting a position number 5. Certainly by the locant rule, if you move along this pathway, I can say the clockwise, the locant set is 3, 5. Whereas if you go this pathway, the locant set is coming 2, 4, and the lowest locant rule is to be considered as finals 2, 4. 2, 4, that is at position 4 I will find bromine, position 2 is methyl, so answer has to be 3, 4 bromo 2 methyl. This is also very important, cyclopentane carboxylic acid. You cannot use something like pentanoic acid. When this COH cannot be included in parent chain, then we have a special suffix for carboxylic acid functional group. That suffix is carboxylic acid. Is that correct? So answer is 3rd. Moving to next question. It is when neopentyl alcohol is heated with an acid. As neopentyl alcohol, so I'll take neopentyl alcohol structure, which is CH2OH. Not define which acid, but as the products are exhibiting alkene, I prefer use of concentrated H2SO4. So let me exemplify with concentrated H2SO4. So if I use concentrated H2SO4, definitely a carbocation is formed, CH3CH2OH2 plus. Then this goes, we'll have CH3CCH3CH3CH2 positive. It will undergo rearrangement, CH3C positive, rearrangement through what? Through methyl shift. So this is my carbocation. Now if I have this as a carbocation, let me redraw it here, CH3C positive, CH3CH2 CH3. ZZF rule is the major product controlling rule in this type of reaction. So my major product is CH3C CH3 double bond CH single bond CH3, and definitely I will have a minor product which is this. Right? These are my choices. Now let me go to the question again. Is heated with an acid, it's slowly converted into 85:15 mixture of alkenes A and B. A and B. This is our major, so this must be in the ratio 85. This is 85:15. So this must be our minor product. What are these alkenes? So following what we have just solved, I think all of you will agree to our answer 2. Okay, is that clear? So moving to next, this is our next question, which is peak on treatment with bromine with FeBr3 and CCl4. CCl4 is functioning as a solvent. Produced a single isomer C8H7O2 Br. As it says only one Br, we have to consider mono bromination on the ring. While heating P with soda lime gives toluene. That is also compulsory that on heating it should form toluene. Correct? So if I go by this, that on heating it should form toluene, I don't find any of the options is of any help, because all of them on heating can form toluene. Okay. Now the point is that it will produce a single isomer with FEN, FeBr3 and bromine. Let us go to that point. In option number 1, if I have the given reagent reaction, I can have bromine here. In such questions, we go by the directive influence and the IUPAC name. Okay, so I can have here that it is an orthoperic directory of CH3 group, which will control the position of incoming electrophile. So there are 3 possibilities like this. If we go to number 2, option number 2, COOH is deactivating, CH3 activating. If I consider the same reaction, COOH, CH3, whether I have bromine on the right or on the left side, IUPAC name is remaining same. So definitely this is our choice because it says single isomer. Correct? In 3, similarly, you will get ortho, either will give 1, or from this para another second name. So they are all giving more than 1 isomers as a choice if I go by number of isomers produced in the reaction. Is that clear? Moving to next question of organic, we have at question number 8. This is our next question. An organic compound A, always underline the molecular formula. C6H12O2 was hydrolyzed with dilute H2SO4 to give a carboxylic acid and an alcohol. Okay, so it is an ester that is indicated from the options very clearly. Right? Now this on hydrolysis will give CH3COH plus 2-methyl-1-propanol. Second one on hydrolysis will give me propanoic acid plus N-propanol. Third will give me ethanoic acid, 2-butanol. Fourth is giving me ethanoic acid plus tert-butanol. Right? So what it says next? C gives white turbidity immediately when treated with anhydrous ZnCl2 and concentrated HCl. This anhydrous ZnCl2 and concentrated HCl, this is a very famous reagent. I expect all of you do remember. It is our Lucas reagent. And when it says it gives turbidity immediately, if it gives turbidity immediately, this particular point indicates that an alcohol should be 3-degree alcohol. Now, as I have drawn all the alcohols, you can directly conclude that option number 4 is our answer because it is giving us 3-degree alcohol, which is indicated in the question. Is that okay? So our answer is option number 4. Our next question is number 11. Which of the following will react with chloroform plus alcoholic KOH? Now here chloroform plus alcoholic KOH, and the options are different types of compounds containing nitrogen. All of them, adenine, lysine, thymine, proline, whatever there are in the options are all the nitrogen containing compounds. Now they say reaction with this. What is that reaction? So when primary amines react with chloroform plus KOH, then they form RNC. This is a very famous reaction known as carbyl amine reaction. Now, in the given choices, I have to check in which of the options they have mentioned. I have a free primary NH2 group available. That is our answer. So, first is adenine. Now, if I draw adenine, adenine is NH2. You will get all these structures directly from NCERT and it will be of help to you. Correct? Here there is a double bond. So this is our structure of adenine. Next it is thymine referred. So let me draw thymine. Thymine is CH3 double bond NH C double bond O C double bond O NH this. Next they are mentioning proline. Proline, all of you have to remember, it is very important because it is the only amino acid which is having 2-degree amine group at alpha position. So it is a very important amino acid otherwise also. Next is lysine. Lysine is NH2 CH2 4 times CH NH2COOH. So once I have drawn the structures, you can clearly see that the free primary amino group is available only in adenine and lysine. Right? No such thing in thymine and proline. So our answer has to be first. Clear? Next question that is there for us is question number 17. Let us move to question number 17. What are the functional groups present in the structure of maltose? In the structure of maltose. Okay, so first I need the structure of maltose. It is a disaccharide and it is formed by alpha D glucose and alpha D, 2 molecules of alpha D glucose. Let me draw the structure for you. OH, H, H, OH, OH, H, CH2OH and down H. Coming similar here, H, OH, OH, H, H, OH, CH2OH and H. Okay, this is the structure of maltose. Now what they are asking is acetyl word, ketal word. So when an aldehyde combines with 2 moles of alcohol in presence of dilute HCl, or rather I should say in presence of HCl, then RCHOR dash OR dash. On the single carbon, 2 OR dash of are present on the aldehydic carbon, then it is known as acetyl. If it would have been RCHOHOR dash, then it is called hemiacetal. If I would have repeated the same thing, but my starting point would have been ketone, then I will use the terms like ketal and hemiketal. But as maltose is formed from glucose, so it is an aldose sugar. So here the term ketal is irrelevant. I cannot have the word ketal. Both are aldehydic monomers, that is the 2 alpha D glucose monomers are used for preparation of maltose. So I will expect that it will be either 2 acetyls or acetyl and hemiacetal. Now let me see what it is. So this is the carbon having 2 oxygen. This is the carbon having 2 oxygen. Both oxygen are further connected to carbon. So see, this is the this is the acetyl linkage present in the maltose. Okay, so there is one acetyl, that is clear. I have to talk about the second. If you see the same way, the second one, this is the hemiacetal linkage present in the molecule. Hemiacetal linkage present in the molecule. So the conclusion is the functional groups present in the structure of maltose is one acetal and one is hemiacetal linkage present. Answer is 4. Our next question is 19. The decreasing order of reactivity of the following organic molecules towards AgNO3 solution. Though they are not defining which type of AgNO3 solution, usually it is always aqueous. So first let me tell you what reaction takes place if I take this reaction in aqueous AgNO3. If I take this reaction in AgNO3, basically finally it forms alcohol and AgCl precipitates, white precipitate. Okay, AgNO3 is SN1 catalyst. But this is formed by or formed through carbocation, formed through for R plus carbocation. RCl converts to R plus and this plus is attacked by water forming ROH finally. This is the overall reaction. Now we are asked the decreasing order of reactivity. So which will react faster? The one which will form more stable carbocation. That is the key to this question. Now which carbocation, what carbocation? Let me tell you. A is forming an aromatic carbocation. B is forming an aromatic carbocation as well. But what is the difference? Difference is the OMe. OMe is further giving you plus R, further stabilizing that particular aromatic carbocation. Moving to C, we have 2-degree carbocation. Moving to D, yes, we again have 2-degree carbocation, but I think all of you will agree this NO2 will destabilize it. So, the order of stability of carbocation will be same is the order of reactivity. Order of reactivity है यहाँ पर same है वो दोनों same है. Now which is most stable carbocation is B, then it is A, then it is C, then it is D. So BACD answer should be fourth option, and which is the answer? Fourth option. Next question of organic is question number 21. The number of chiral centers present in B is. First, let us draw what this B is. Then we'll think about the chiral centers. Now, the given molecule is a cyano compound, C triple bond, and this is a very important reaction given in NCERT. That's C2H5 MgBr, use of Grignard followed by hydrolysis. It is a method of preparation of ketones using the same that is given in NCERT. I am proceeding. CH3, C double bond O, C2H5. This is my structure A. Now it again says that okay, make it react again with CH3 MgBr and followed by water. Again we have to react it with Grignard, but this time the reaction of Grignard is of ketone. So after reaction with CH3 MgBr, the structure obtained is this. This is our structure B. Okay, CH3 बड़ा छोटा सा हो गया, इसको थोड़ा considerable दे हम CH3. Right? Now let us see how many. The question says the number of chiral centers in this particular molecule B is. So let us see where they are. First chiral center is this one. Second, you have this one. Third, it is clearly apparent Fourth is this one. So answer for this integer should be 4. Right? As per the given instructions, you may fill it as 04 or 0004, but it is 4. Right? So I hope all of you have completed this fourth morning paper and all your possible doubts are now cleared. Let us now end our discussion here, and you can again expect us to give you more discussions on physical and inorganic by my colleagues. Thank you, everyone.
Hello everyone. So here we are again discussing 4th of September 2020 JEE mains paper of afternoon, or you can say second shift. We'll be focusing primarily on organic chemistry. So let's start with the discussion of the paper. I hope you can see the paper on your screens. As I said, I'll be discussing the organic question paper, organic questions in this paper. So let us see organic question. First is itself an organic question. In the following reaction sequence, C is, we have to find this, what is the C? Let us see. To start with, we are given paratoluidine. Now when this is made to react with NNO2 plus HCl at 0 to 5 degrees centigrade, then I'll have diazonium N2 plus Cl minus and CH3. Now it is made to react with CuCl2 plus HCl. It is Sandmeyer reaction, यहाँ chlorine and CH3. So this is our structure A. Now it is said it is reacted with chlorine in presence of sunlight or photons. So it is a free radical substitution reaction, and it will not take place on the aromatic ring. The side chain, alkyl side chain, is going to be substituted. So this is our B. Let me write B again here. It is this B which is subjected to Wood's reaction. Sodium plus triether. This B is subjected to Wood's reaction. This is the chlorine attached to aromatic ring. Aryl halide centers do not react in Woods. So 2 moles of this will now combine, and this is the structure major product C, which will be obtained in this particular given question. So this C is given in option number 1. So correct answer for this particular question has to be 1. Next organic question is the third one, which says among the following compounds, which one has the shortest carbon chlorine bond? So if you observe in option number 4, which is CH2 double bond CH single bond Cl, there is presence of resonance between the chlorine lone pair and the pi bond of the 2 carbons. As a result, there is a double bond character in carbon chlorine bond in the hybrid molecule. This double bond character will certainly reduce its bond length. Right? There is no other molecule in the given question which is having this type of resonance. A pure single bond, correct? And here it is again a pure single bond. This is the only one which is having a resonance. So our partial double bond character will be created in this particular molecule. So answer has to be option number 4. Next question of organic is question number 5, which says which of the following compounds will form the precipitate with aqueous AgNO3 solution most readily. First, let us see what is the reaction of alkyl halides, as in the question all are alkyl bromide. So I am writing alkyl bromide when we are asked to react with aqueous AgNO3. R positive plus precipitate of AgBr will be formed. Okay, the precipitate obtained is of AgBr. This R plus is formed. Now this R plus, when water reacts with that, it finally forms alcohol. But RDS is this R plus. Now we are asked which will give the precipitate more readily. Here the word most readily refers to with the ease, with the rate, fast formation of precipitate. So definitely this RDS will be faster if the stability of this involved carbocation is more, right? So let me write the carbocations involved. If I say in option number 1, the carbocation formed is this. It is not even resonating with any of the lone pair. It is simply hyperconjugative, so it is not of much use. Moving to option number 2. Option 2 is having a carbocation like this. It definitely has a resonance of this nitrogen lone pair, which will be very, very stabilizing as it will complete the octet. Yes, there is again a carbocation which is having complete octet with this nitrogen. It could have competed with option number 2, but here this lone pair will also go for resonance in the ring. So its availability for our carbocation stability is decreased. It will be less stable. Moving to option number 4, which is oxygen lone pair. So 2 and 4 are similar, that only this carbocation is enjoying the lone pair resonance of the adjacent atoms. But as nitrogen is less electronegative than oxygen, so plus R, or the donation capacity of this nitrogen, is better, stabilizing the carbocation involved to the better extent, and so the answer has to be option number 2. I hope that is acceptable, is correct. Next, our question is number 10. The question says the mechanism of action of terfenadine, which is Seldan. NCRT, page number, you can find this exact thing. NCRT 12th chapter is chemistry in everyday life. Page number 444. You'll find the exact statement that I'll be repeating to you. So what is Seldan? Seldan is a antihistamine. It is an antihistamine. Histamine is a type of chemical. It is found in our body. Okay, so what do they do? Antihistamine, they interfere with the natural action of histamine. Okay, they interfere with the natural action of histamine by competing with the histamine for binding sites of receptors where histamine exerts its effect. So it competes with the histamine and thereby decreasing its reception at the binding sites. So inhibits the action of histamine receptor. Answer has to be 1, right? Our next question is number 14. Let us see what it says. The major product R is being asked in the following sequence of reaction. Let me first solve what is being said. Acetylene moving to LiNH2 in ether. Acid-base reaction will take place. Yes, there could have been reaction on both sides. But if you see the number of carbons mentioned in the products, right, you will automatically get the hint that only one side is to be taken care of. Now this is made to react with CH3, CHBr, CH, CH3, CH3. Here there is an SN2 reaction taking place. So the product formed is CH triple bond C, CH, CH3, CH, CH3, CH3. This is our structure P. Okay. Now this P is made to react with HgSO4, H2SO4, and it is also in continuation made to react with NaBH4. So if NaBH4 is given in case of alkynes, certainly the answer will become alcohol. It is a Marconic of addition of water here. So it is CH3, CH, OH, CH, CH3, CH, CH3, CH3. This is structure Q. Now with concentrated H2SO4 it is made to react, and heat, that is an E1 reaction which is to be considered. If E1 reaction is to be considered, we'll form a carbocation and will rearrange. So our rearranged carbocation will be CH2, CH3 positive, CH, CH3, CH3. This can certainly lead to two different alkenes. One, the ZZIF, which is going to be major, that is more hyperconjugative, more substituted, and the other, which is going to be minor. Let us draw the possible. So I'm drawing first the major one, CH3, C, CH3, CH2, डबल बॉन्ड यहाँ पर C, CH3, CH3. As it is not showing any geometrical isomerism, so I'm not worried which side to draw, what to draw, and all those things, right? But if it would have had, then definitely more possibilities could have been there in the answer. This is going to be minor CH3, CH3. Yes, a very, very small amount of this product could also be formed. But in the question, in the option, this is the one which is going to be the major most, right? This is the one which is going to be maximum in concentration. This is going to be major. This is going to be minor, right? If this is going to be minor and this is going to be further minor, so here we are asked major product. So automatically your answer is first. You will check the structures. This first is matching with our answer solution. Okay, next our question is 17 number. Let us go to that. Again, the question says the major product C of the following reaction sequence will be. Okay, so let us start. CH2 double bond CH single bond CHO is made to react with NaBH4. No effect of conjugation, no effect on double bond. It will be simply reduction of aldehyde to alcohol. This is now react with SOCl2. Again, I would say as it is non-substituted, no effect. Simple chlorine will go on one side where OH was written. Answer is allyl chloride. Now this is made to react with benzene in presence of anhydrous AlCl3. This is our very famous Friedel-Crafts reaction. As a result of this Friedel-Crafts reaction, you'll get CH2, CH double bond, CH2. This is structure for B. Now it is said this reacts with DBr. So I'll have D positive, Br minus. For more stable carbocation, the structure formed will be pH, CH2, CH positive, CH2D. Correct? And rearrange positive, CH2, CH2D. Now this is being attacked by Br minus. So final answer has to be D and bromine here. So see, they are relatively positioned one and third. Answer is first. Is that okay? Right? Our next question is number 20. The major product B in the following reaction is. Okay, let us again proceed with the reaction. See, all these single correct options question are always asking major product. They are very clear. Right, major product. Even by fault, if in case they would have not mentioned, then if it is a single correct, we should always answer the one which is major product. So here it is clearly mentioned. Let's start. First reaction is HI, heat on ether. So CH3, CH2, CH, CH3, CH2, O, CH2, CH3. Reaction with HI. First, there will be protonation. So I will have EtCHMe, CH2OH positive, CH2CH3. I minus attacks by SN2, less substituted. So this is what will happen. So I will have alcohol as EtCHMe, CH2OH, and alkyl iodide as CH3CH2I. Correct? Now A is an alcohol, so this is our alcohol. It is now heated with H2SO4 heat in presence of acid. So it is again even reaction. We discussed in the previous question that there will be rearrangements involved. CH, CH3, this is the rearranged carbocation I'm drawing. Okay, this is our rearranged carbocation. It is not just the carbocation formed, it is the rearranged carbocation. 1 degree will be formed. By hydride shift, it will move to 3 degree, and this is the 3 degree carbocation I'm using. Now again, this 3 degree carbocation is to be uh, eliminated to alkene. More substituted, as I have been repeatedly telling you in last few questions also this concept came. So major is ZZIF. Major is ZZIF alkene. Let us check which is satisfying our answer. It seems this first option in this given paper is the right answer. Is that okay? Now let's see which is our next question. It is 21. No, it is 22nd. Very simple, very nice question. The number of chiral centers present in threonine is. Threonine is one of the amino acids. First, we need to know the structure of threonine. After January papers, I hope all of you must have learnt all the amino acid structures given in NCERT, as well as the drugs mentioned in chemistry everyday life structures. If you have had done that, then no issues, just draw the structures of threonine. This is what threonine is. In this threonine, once you draw the structure, question is very simple. Number of chiral centers. I have marked the number of chiral centers. So answer is it has 2 chiral centers. Okay, so threonine has 2 chiral centers in it. I think after this there is no organic question any further. Correct? So here it brings us to the end of discussion of organic paper. I hope all your confusions, if there are any, must have been resolved by now. So please go through this. If you have any further, you can definitely ask your respective teachers. But what is the final extract of the paper is certainly that all the questions, whether 4th of September shift 1 or shift 2, are very much within the syllabus as per mentioned by NTA and is entirely based on NCERT. So if you would have had done the NCERT, reading thoroughly and would have practiced the structures, there is nothing which can stop you from scoring up to 100% in these papers. Anyways, all the best. Take care. Bye-bye.